Now, in this lesson, we continue with our investigation of Euclidean geometries, and we enter specifically into this polygon, which is known as parallelograms. Parallelogram is, a four-sided polygon, just like a rectangle and the other shapes. And we will be going through a few of the properties really quick. We will check through a few of the properties in parallelogram, and that way we will also do what? We will be able to see if we can go ahead with what? If we can go ahead with applying these properties. We will first state the properties, and after stating the properties, the next thing we will now be dealing with is to go ahead and apply these properties. Then as we apply the properties, it's also going to be important for us to look into the aspect of getting the properties, like deriving the properties. Like after stating it, we also need to be sure that, well, we can generate the properties by ourselves. So before wasting time, a parallelogram is what? Is a quadrilateral. That is a four-sided polygon. This word quadrilateral means four-sided polygon, okay? This one here, it means four-sided polygon, like that. Now, this four-sided polygon behaves in such a way that it has got both opposite pairs, okay, with both pairs of opposite sides. So this one, A, B, C, D, is a parallelogram, okay? A, B, C, D is a parallelogram, and just a minute. Right, so this one here is a parallelogram. ABCD is a parallelogram right there, and this parallelogram has got the properties we are going to be investigating. The first one is that if a quadrilateral, if a four-sided polygon is a parallelogram, then its opposite sides are congruent, meaning AD, which is opposite to BC, they have got the same value in length. Also AB, which is opposite to DC, also has got what? Has got the same length. That is what they're actually trying to mean. AD and BC, okay? We could say AD equals to what? Equals to BC. Yes. And the other thing is that AB also equals to what? Also equals to DC. That is the meaning of the first what? The first statement, which is what? Which is that opposite sides are congruent. They are similar and have got the same value in length. Now, the other property, okay? We're going to be listing them one property at a time. We would like to call this as property 1 in a mathematical representation. So this is what? Property 1. Yes. Then the other property that we also want to include in our discussion is the second property, which is what? Which is property 2. So we would like to put it here. This is going to be property 2. What is property 2 in a mathematical way? Well, let's read it. It states, its opposite angles are congruent. That is, the angle at A equals to the angle at C. See, that is what it means. The angle at A. The angle at A, well, how do we represent angles? Right here, let me see real quick. If we do have a representation of angle at A, a proper representation for angle at A, well, yeah, we do have it right here. Angle at A equals to angle at what? Equals to angle at C. So angle at A equals to angle at C. So we write it there, equals to angle at C. Like that. What else? Angle at B, okay? The angle at B. This angle here is also opposite to this other angle. And so they are also equal to each other. So we say it's also opposite to angle at what? At D. Like that. Well, what else do we have? We now move on to the other property. We want to find a mathematical representation of now the third property. What is it? consecutive angles are supplementary. Consecutive angles are supplementary. What this means in a mathematical way is that angle B, rather angle A and B, add up to 180 degrees. So this is what they're saying. Angle A and, okay, and angle B add up to what? 180 degrees. Also, angle B, because you know we don't skip an angle. If we are moving from A to B to C to D to A, we move from A to B, then B to C, not like AC. We don't skip. That's the meaning of consecutive in this case. You know, we follow a pattern one after the other like that. So we now move to B and C. So we say the angle at B and the angle at C gives also 180 degrees. The other property is that the angle at C and the angle at D, okay, the angle at C and the other angle at D, okay, also adds up to what? 180 degrees. That is the meaning of supplementary. Then finally, D and A, or A and D. So since we are moving, you know, in that clockwise direction, we are going to have D and A. So we say the angle at D added to the angle, okay, at A must give us 180 degrees. That's the meaning of the third property, which is right here. This is the third property. That what? The third property is that supplementary angles, okay? That consecutive angles are supplementary. Consecutive angles are supplementary. Then now we move to the mathematical representation of what? Of the other property, which is what? Which is property 4. Yes, property 4. Well, now what does this mean? Its diagonals bisect each other. What does it mean by that diagonals? Diagonals represents these lines here and this one here. They bisect each other means they meet midway, okay? They meet and they divide each other into 2 equal parts. What this means is that AE, okay, the length AE equals to the length EC. That's the mathematical representation. The other thing is that the length BE also equals to the length ED, okay? That is the mathematical representation. Now it makes sense that we have to look at how we apply this mathematical representation real quick, okay? We'll be applying them right away. Now, here is the quick question. Show both pairs of opposite sides of A quadrilateral congruent. Well, we are supposed to show the opposite side. Well, opposite side is that BC here is opposite to AD and AB opposites to what? To CD. Then for the second one, it's still the same thing. Show both pairs of opposite angles. This time they are talking of angles. So we have B opposite to D, A opposite to C. Then show one pair of opposite sides is both parallel and congruent. This pair, AB and CD, they are congruent and also parallel. Then BC and AD are also congruent and parallel. Show that both, okay, show the diagonals. Show the diagonals. Show that the diagonals bisect each other, okay? We are supposed to show that the diagonals bisect each other. Well, that BE equals to ED and that AE equals to what? EC. Well, basically, what we are supposed to do in this section, ways to prove a quadrilateral is a parallelogram. Well, we should be getting this. This one requires use of some properties, which we should be seeing immediately. But before dealing with that, I would like us first to deal with this calculation instead. I would like us first to deal with the application of this. You know, before we get into the technicality of proving these properties, let's first use them. Let's see how they work, if they can help us find things nicely. Okay, so we will be moving right away into what? Into these other activities. And we will first see the questions right with us here. You see? So the thing here is we are supposed to solve for the variables. How do we solve for this variable? Well, we would like to call this activity 1. So activity 1 has got, well, 2 variables that we have to look for. The first variable being what? A, and the second one being B. Now, notice that we have already seen that B plus 2 and these other sides here, they are opposite sides and they are also congruent. What that means is that B plus 2 gives 7. They are the same in length. And so can we find the value of B? Yes, B is going to be equals to 7 minus 2. No, notice that when we transfer B from the left-hand side and we move it to the right-hand side, it becomes minus, since initially it was positive. So that way we can find the value of B, which is what? Which is 5. So that is how we would handle the case for the value of B. The other thing is to find the value of A. Also, A minus 3, well, we have it that A minus 3, which is on the left-hand side here, equals to what? Equals to 14, because those two are parallel and they're also congruent. So real quick, we can then say A equals to what? A equals to 14 plus what? Plus 3. That way, we can conclude that A equals to what? 17. Now, we are done with that activity. The next thing is for us to look for the solution to activity what? Activity 2. Now, activity 2 has it this and that, the sides and the angles. Now, the thing we know is that these sides here, they are parallel. This one here, where there is 3x plus 4 and there is 16. So what do we do? Well, we can go ahead and say 3x plus 4 is parallel and congruent and opposite to 16. So what is that supposed to mean? That's supposed to mean we can find the value of 3x. 3x is going to be 16 minus what? Minus 4. Now notice that we get minus 4 when we transfer this positive 4 from the left-hand side to the right-hand side. It becomes negative 4. And that way we get what? 16 minus 4. So from here, we can then write 3x equals to what? 3x equals to 12. The next task is to find the value of what? Is to find the value of x. So how do you find the value of x here? Well, to find the value of x, we have to divide what? We have to divide 3x by 3. So when we divide 3x by 3, right here, when we divide 3x by 3, on the left-hand side, we are going to be left with x. Then on the right-hand side, we will also have to divide what? 3x by 3. No, not 3x this time, it's 12 by 3. That will give us a value of 4. See that? So that is how we find the what? The value of x. Next thing, the angles, okay? We are now done with the lengths. Now the angles. So for the angles, we have this one, 56 opposite what? Y minus 60. So we can write y minus 60 degrees is opposite to 56 and also equal to 56. So can we find the value of y in that case? Yes. Y can be calculated when we add what? When we add 60 onto 56. That way we can find the value of y. Well, what is it going to be? Well, this is going to be 116, right? Yes. So we can write 56 plus 60. We get 116. So we write it down there. So this is going to be the value of angle y, which which is what? 116 degrees. Now, that is for activity 2. Now, for activity 3, I would like you to try it out, but I will create it for you. So now notice that this angle is opposite to this one. Okay, this is what? This is 2G. It's not nice to start with that. No, let's not start with that. This is going to cause us problems. Let's first deal with these two because we cannot deal with the two unknowns. Let's first look at 72 and what? 72 and 2G. Now, 72 and 2G are known as supplementary angles, okay? And because of that, they add up to 180 degrees. I've already indicated for you here. Supplementary angles, they add up to what? To 180 degrees. So now that's the next thing we want to deal with. So we say 72 degrees and 2G, okay? They are what? Supplementary angles. And so they add up to what? 180 degrees. This way, we can find the value of 2G. When we transfer 72 from the left-hand side to the right-hand side, so that we get 180 minus what? Minus 72. That way, 2G is now going to be equals to what? 72 minus what? Rather, 180 minus 72, which gives us the value of 108. So from here, we can find the value of G. How do we do that? Well, we have to divide 2G by what? By 2. And what we have done on the left-hand side must also be done where? On the right-hand side. And so we have 108 divided by what? Divided by 2. Okay? So from that, we get the value of G as what? Well, this is going to be 54. Yeah, we could check it out right away. Divided by 2, 54, yes. So that's what we get. Also here, just checking this. Yes. So that way, we can find the value of G. Now, after finding the value of G, the next thing we want to do is to find the value of F. Now, the thing we know is that this F plus the 30 and the other angle, which is 2G, okay? Plus this 2G, they are opposite and so they are equal to each other. So we can put equal sign instead, okay? So because of that, we can now write F plus 30 equals to 2G. But we already know G is 54. G is right here. So we can say that value times, okay? Times G, which is 54. So that way, F is going to be equals to, that is F plus 30 is going to be equals to, what is 2 times G? This is 108. Now, can we find the value of F? Yes, F can be calculated. When we do what? When we transfer 30 onto the right-hand side. And so F is going to be equals to, well, 108 minus 30. Let's check. Sorry. 108 minus 30. This gives us 78 degrees. So the value of F is 78. Oh, yeah. So that's how we could handle that question. Then now, I thought I was going to just set it and leave it for you, but you know, I just ended up doing it. How about activity 4? Is there something I can leave for you here? Well, let's just discuss it and possibly leave for you something else later. Now, for activity 4, okay? For activity 4, we're dealing with this. Now, these are now the diagonals. For the diagonals, we say they bisect each other. Bisecting each other means they divide each other into 2 equal parts, meaning this part equals to that part and this one equals to that. So when we start with this other one here, we can see that 3 of j equals to 5 of j minus 9. So from here, can we find the value of j? Yes, we can find the value of j. What we do is we take 9 from the left-hand side to the right-hand side and we bring onto the left-hand side. We take 9 from right-hand side, bring to left-hand side. Or we could take 3 from left-hand side and we transfer to right-hand side. Or so many options now. We could transfer 5j onto the left-hand side. When we transfer 5j onto the left-hand side, we will leave 9 that way. So let's do it like that. So it's going to be 3j minus what? Minus 5j equals to what? Equals to minus 9. Like that. Now from here, we are going to be left with what? Minus 2j equals to minus 9. Notice that 3j minus 5j, we are taking a bigger number from a smaller number. That's the reason we have a minus or a negative. So from there, we can do what? Well, from this one, we can find the value of j. That is minus 2j will now be divided by what? Will now be divided by 2. Like this. Then on the right-hand side, we are going to be having minus 9, which we also have to do what? We also have to divide by minus 2. Like that. So this way, we can find the value of j as what? Well, 9 over 2 or 4,5. Now, the next thing is to find for us the value of k. The things are the same. We also have it that this side equals to that. So we can say 6 of k equals to what? K plus 10. Why are we equating them? Because they are divided into 2 equal parts by this what? By this line here. So can we find the value of k? Yes, we now do 6k minus k. That is when we transfer the other k from the right-hand side to the left-hand side. Now equals to what? Equals to 10. And so we can write 6 minus 1 is 5. So 5k equals to 10. In the next step, we now divide what? We now divide 5k by 5, okay? We say 5k divided by 5, okay? 5k divided by 5 equals to what? 10 also divided by 5. Like that. That is what we have done on the left-hand side must also be done on the right-hand side. So that k now equals to what? 2. So yes, that is how this first section of parallelogram works. The only section which should get us into the next discussion in the next lesson is going to be the properties, okay? Showing what? Showing this. This is going to be in the next lesson, ways to prove that quadrilateral is a parallelogram. That is going to be the last part. And when we are done with that part, we will be done with basically everything. And so from that, we can kick on to a new section. So let's stop there.